overview of why we're here and give a little bit of background to why we're having a conference and what the impetus is and what our goals are. So we began a new research program just this last year, about a year ago, with the Navy that is concerned with tactical communication. And this means communication in time of warfare, communication for soldiers. And it has some differences between what we consider normal communication. So our goals are myriad, and we'll speak to those in some detail during the course of the conference. And we are kind of approaching the problem of communication from the perspective that we would like communication to be efficient and effective and fluent, and to not step on the toes of the warfighter. When they're using the technology, we want the technology to be easy for them to use. We want it to be accessible to the broad range of users that we have within military operations. And we, at this conference, however, are not focused on military applications. We are talking here about the broad world of visual language. And in that respect, we don't expect conversations to focus on what our end goals are. We would like everyone to bring their own applications and their own ideas to the forefront so that we get an idea of how we might apply methods used in education that utilize visual language, or methods used within sign language communication or gesture, because we feel that all of these myriad fields are very applicable to our end goals, even if we don't directly address those problems at this conference. So without further ado, I'd like to introduce our first speaker.
I'm not ready.
Oh, you're not ready? Well, we can give you as much time as you need. I would also like to thank all of you guys for attending the conference. I think it's great that we've been able to draw in so many people from so many different knowledge areas and from so many different parts of the country. We intend to have a conference again during next year, and we hope that all the folks that we have here today will return and bring their colleagues, because hopefully we'll have such great speakers, and I believe we do, that you won't be able to help yourself but come back and maybe even present yourself. During the course of the conference, we're going to take very informal breaks, so whenever we need to, we'll just break for 10 minutes, and there should be people trickling in probably for the next half hour or so as well. So is there any questions as we start things off?
Okay, I'm ready.
Well, I discovered Dr. Chang's work in my doing background research in visual language, and I know just a little bit about his background. He's been a part of several different university programs, IBM Watson Research, and he's currently director of the Center for Parallel and Distributed and Intelligent Systems at the University of Pittsburgh. Dr. Chang has published over 240 papers and wrote and edited 12 books. And he is currently the editor-in-chief of the International Journal of Computer Processing of Oriental Language, the Journal of Distance Education Technologies, and I believe a Journal of Visual Language. And without further ado, I will allow Dr. Chang to begin his presentation.
Good morning, everybody.
Good morning.
When Sunny invited me to come to this conference, in fact, I was pleasantly surprised because our community is a rather small community. I mean, a community of people doing research on visual languages. Worldwide, we have probably less than 200 people. And VaIL is news to me, okay, because frankly, I never heard about this group, so for me it's a surprise. But then I look at the agenda and the rationale for this conference. I'm quite interested. That's why I'm here. I'm a computer scientist. I presume here a lot of people are linguists or psychologists, people with different training. So what I do today is that I divide my talk basically into two parts. The first part is more theoretical because I have to set the background of what is a visual language, what is iconic language, and give you some basic ideas so we can bring it to a common ground. I noticed I lost the color, but that's okay. Otherwise, you will see that the first 4 bullet items are in black and the rest are in purple. So first I talk about visual languages, the ideas of icons and iconic languages, what's the difference, and iconic operators. So that's the theoretical part. This is just to set the background. I hope I can spend maybe 20 minutes on that. And the rest of the time, I talk about applications, because I think most of the people in the room may be more interested in seeing how visual languages, how iconic languages can be applied in practice. And of course, I draw upon the experience from my own research group and talk about emotional icons, so-called emoticons, IC cards, in software engineering, ambiguous icons. And finally, I end up with the vision for the future, really as seen by the great historian Arnold Toynbee, and some research issues that are open to be explored. And I'll be staying here for the duration of the conference and hope I can have a chance to talk to every one of you. And finally, a bit of promotion for the Journal of Visual Languages and Computing. This is the flagship journal of our area, and we have international editorial board, and we have been in existence for 19 years now. Next year we'll celebrate 20 years. And you can see the website. If you go to the Elsevier, which is the publisher for this journal. Elsevier, by the way, is the largest publisher of journals. They have, I don't know how many, 2,000 different journals. So this is one of them. So if you're interested, you're encouraged to send your papers to us. I'm one of the 2 co-editors. My colleague, Stefano Liviadi, he's from Italy. So I get a chance to go to Italy every year, which is good. Yeah, I love southern Italy. And I'm the other co-editor, so you can simply send papers to me. I sent the PowerPoint presentation of my keynote to Sunny yesterday. It's always last minute down the wire, so I think it's probably have not been able to make it to the press, but it is online, and you can get a copy from Sunny if you like to. For the application areas for each one of them, I have slides, and also hopefully I can run some demo. But you know Murphy's Law, so when the right time comes, usually it won't work. So we'll see. I asked my assistant to bring up the server and be ready. And then I noticed the time difference of 2 hours. And we are in Pittsburgh, of course. So I hope you're smart enough to realize the time difference. Okay, so different people really have different conceptions about visual languages. In fact, like many things, visual languages mean different things to different people. Of course, I understand many people here are interested in visual languages as a means for human-to-human communication. For many of us who are computer scientists, we have a slightly different view. We are trying to look at it from the computer science perspective. So for the computer scientist, we also have differences in what we mean by visual languages. Some would say visual languages means languages for the processing of visual information, such as images, graphics, and of course, icons. So the object we are dealing with are visual and inherently visual, because photos, you cannot think of it otherwise than an image. So the visual language is meant to deal with this kind of situation. Some others who are more oriented toward programming would say what we want to do is to make programming easier for everybody. So instead of a very abstract language like C or Java, why not have a visual language? In other words, the construct of a language are spatially oriented, and people can easily use this language intuitively for programming. Another camp. So these are the two basic viewpoints. There are others as well. For the first type of visual languages, for visual information processing, so the objects we are dealing with have inherent visual representation. Like I said, there are images or graphics and so on. But those images also have meaning. So if you see the image of a bridge, then you identify that as a bridge. So that's the logical information associated with the visual information. So we want to deal with those visual objects which can be associated with some logical meaning. The programming aspect of it may not use a visual language per se. It could be used a traditional language like C, like Ada, like Java to do the processing. So the language, we can say, is linear in that sense. There are many applications for visual information processing language. This includes image processing, computer vision, robotics, image database management, office automation, and image communications. That's probably the area that many of you here mostly interested in. Image communication can be communication between humans. It can also mean communication between human and computer or human and machine. The other kind of visual language that is visual programming language, then we are interested in trying to use a visual-oriented programming technique to deal with objects that are not necessarily visual. Because in programming, usually we deal with arrays, stacks, queues, documents, databases, etc. So the language itself is visual, and the objects may or may not be visual. And there are also many interesting applications, including computer graphics, user interface design. This has been the focus of the community of people working on visual languages for some time, because we all realize that the interface design is a key to the success of many computer information systems, and so on. But these are not the only types of visual information processing language and visual programming languages. There are other possibilities as well. But the objects we are dealing with can be either inherently visual, like images, photos, graphics, or it can be non-visual. But the non-visual object can be imposed with a visual representation. So I call them derivatively visual objects. For example, if we have a sketch, the sketch itself can be represented by a data structure. And that data structure can be visualized. That's an example of a derivatively visual objects. So the other aspect is visual computing. We are interested in techniques to transform from inherent visual objects to the derivative visual objects and vice versa. So if I have an image, I would like to do image processing, abstract information, and maybe label the objects we detected in the image. So that's from the inherent visual objects to the logical representation. Conversely, if I have abstract data type, a data structure, I may want to visualize it and transform that into a visual representation. So visual computing deals with both. Deals with the abstraction from the visual objects to the abstract, and the visualization to transform from the abstract to the visual objects. So visual languages and visual computings are the two aspects. That's why our journal is called Visual Languages and Computing. Okay. Now, although there are many different types of visual languages, a unifying concept is the idea of icons. Because if you think about it, we are trying to associate a visual object, such as an image, or with its meaning. This is fundamental. If you just have images or just have pixels, that's not enough. If you just have an abstract concept, that's also not enough. So it is this combination that makes sense. So when we look at icons, icons do have meaning. Although I must say, they may not have unique meaning. And that's part of the problem and part of the challenge. Okay, so I regard this as so-called general icons, generalized icons, and they could include object icons, namely icons that represent a thing, and process icons, icons that represent some action. For example, if you have a roadside symbol, no entry, so that's an object icon. But it can also mean stop. That's an action. That's a process icon. So there's also a duality there. In other words, the meaning of an icon really depends upon the context. So sometimes an icon means a noun. Sometimes an icon means a verb, depending upon the context. In fact, my good friend Bruce, I think he will be here. Look at the agenda. We have semantic compaction. Is semantic compaction will be here in the conference?
I don't think we have any presentations.
Oh, okay. Anyway, semantic compaction is the name of it's the name of a company and also their approach. Basically, they try to utilize ambiguous icons for the physically handicapped people to represent. We'll talk about that a little bit later. Here, the main idea is that if I have an icon, it's really some visual representation associated with the meaning. But the meaning part may not be unique. It can depend upon the context. And also it depends upon how we interpret that. So it depends upon context and interpretation. And the semantic part is really quite challenging. And there are a lot of opportunities here for further research. So like I just mentioned, oh, the color comes out. Okay, that's good. So if I have a diagonal line in a circle, it could mean a stop sign. So a computer vision system can pick that up. So that's an object icon in this interpretation. But a mobile robot going that way will interpret that as a hot command. So that really depends upon the interpretation and the context. Okay, now it comes to iconic languages. So we talk about visual languages, which is the broad concept. It covers visual information processing languages. It covers visual programming languages, and also covers visual communication languages. And then I introduce the idea that the icon really consists of two parts, the meaning part and the physical part, the image part. Now, the iconic language is the language that is based upon icons. And in fact, icons can be combined. The simple example is we have a road symbol with a diagonal line, means no entry. In fact, for some of you who are old enough, maybe you've seen the movie Ghostbuster. Okay, I like that movie a lot. So it's a ghost with diagonal lines, no ghost. Okay, so it's an extension of the same concept. So this means that we can combine icons to form more complex visual concept. An iconic sentence is a spatial arrangement of icons from an iconic system. The spatial arrangement could be linear, so you just have a sequence of icons. Okay, that happens often for mobile phone type applications because you don't have enough real estate on the screen, so you just have a linear sentence. It's still an iconic sentence. It can also be spatially arranged. A good example is our mathematical expression. Mathematical expression is typically two-dimensional. So you have those icons, but you arrange them two-dimensional so that if you have a line B, you know it's A divided by B. That's also an iconic language. So the iconic language is a set of sentences constructed with given syntax and semantics. And it can be used in many different areas, different applications. I'm sure we'll explore that in this two-day conference. Of course, iconic languages have problems and drawbacks. Like already mentioned several times, the interpretation is always context dependent and content dependent as well. And icons can be ambiguous. As I've tried to point out, we probably can exploit this ambiguity to our benefits. Because typically in user interface design, you don't want to have a very large set of icons. There's an earlier research done by IBM Scientific Center in Europe. The cognitive psychologists look at how many icons present on the screen will be most effective. And their answers is between 20 and 40. Okay. Because you have, if the screen is cluttered with many icons, the user will tend to be distracted and doesn't know how to focus. So there's a limited number of icons you use. And incidentally, this also point out the problems when we have overlays. Okay? So if you have many icons, you have pages of overlay. And the user sometimes had a hard time trying to figure that out and go to the correct page. Up to now, there's no universal set of icons. And I think some of these issues will also be discussed tomorrow. Because there's no standard set of icons, icons can evolve in time. In fact, I already noticed that the Italian icons and American icons are very, very different, so we use that differently. Sometimes it can lead to unpleasant consequence. Okay. So design process of icons must be well thought of, including choosing the representation, random design, and doing a lot of experiments for testing the user acceptability. All these are well known, so I just want to point that out. Okay, so I talk about visual languages, icons, and iconic languages. The last thing in this theoretical framework are operators or iconic operators. Like I mentioned, icons seldom exist in isolation. Of course, these day and age in the desktop metaphor, you just click. You click on individual icons. However, the icons usually have some arrangements, and they can either be composed together to form a more complex icon, like the no entry situation, or form an iconic sentence, either linearly or in 2 dimensions. We have not seen many 3-dimensional cases, although some of my colleagues are working on 3-dimensional language as well. So once we are talking about trying to compose iconic sentence from these icons, then we need some operators. Well, even in a linear language, we know we also have an implicit operator, namely the concatenation. You concatenate symbol to form a word. So in the visual case, we have also iconic operators. The key point I want to make is that those operators not only operate on the visual aspect, it also operates on the semantic aspect. So this duality I try to emphasize. In other words, when you put in the icons together, so visually you can see an arrangement. Conceptually, if you use, say, conceptual graph to represent those entities, those conceptual graphs also interact to form a new meaning. So the icon operators operate on duality as well. So there's a physical part and a logical part. I don't want to go into any much mathematics, but basically the operator has the part that operates on the meaning and the part that operates on the image. So again, going back to my example of having the road sign and the negation, the diagonal line. When we combine them, so physically we are superimposing the 2 icons. But conceptually, you form a new concept called no entry. And we can look at binary operators that operate on 2 icons, or unary operators that operate on single icons. And I will just give 1 or 2 examples. One example, what I already mentioned, of the no entry symbol. So from the image side is the superposition of the 2 images into one. And from the meaning side is the conceptual merge of the underlying concept. Another one I want to mention is the concept of indexing. So we often see a cartoonist draw the caricature of a politician. And you immediately recognize politician, yeah, which is really a reduction from the original image of that politician. So there's a reduction process. So in iconic indexing, you can reduce the image, like the caricature sketch or the silhouette. There are many techniques to construct a simplified image. And there's also a concept reduction. So the original object, like the politician, may be rather complex with many attributes, but you reduce it to a nickname or something. That's icon indexing. And this turned out to be a very useful concept, especially these days when we have Google search going into image search. So how do we index images? How do we use the concept of icons and aggregate things? These are very interesting and important topics. Okay, so this sort of summarized the theoretical framework. So we talk about visual languages as a unifying concept of many different types of visual languages. And we talk about icons as a unifying concept of combining meaning and image. And iconic language, which is what you are focusing on, presumably, and concept of iconic operators. In fact, iconic languages can be used both as a programming language and also as a representation for human-to-human communication. So in more than one sense, it can be regarded as the core of visual languages. Okay, so I'm done with the theory part. So now the fun part, applications. Now, of course, I'm at the mercy of my students. See, I hope that some of this will work. Okay, first is, well, I also have a plan B, so I first give you the slide presentation, then I go live to see whether I can give you the real thing. Icons are icons that can be used to represent the emotional state of a person in communication. A few years back, my students and I developed a virtual classroom system, which is currently in use when I'm teaching. This virtual classroom, I'll show you in a minute, it basically consists of a classroom. And in the classroom, every person will be represented by an icon. So you can see here this virtual classroom. And of course, the icon will change color if the person is present. So normally it's gray, and if the student is here, his color changed to yellow. And the teacher is in the front. And then the participants can send short messages, push web pages, push PowerPoint presentations, and use text to synthesize speech, to use voice communication. We also link up to Skip so that we can use Skype to do voice communication. A good tool. And then, since my research is in visual languages, and I decided to add the icons for communication, these emotional icons you can see there. So the student can express their pleasure with the lecture, or they don't understand, so they can have a sad face, or they can wink at me. And if they really don't understand, they can cry. So there's 4 basic icons. And then they can sum up and sum down. So if I want to schedule an exam, I can do a visual poll. So it's just like in the classroom. So that's really quite useful, these emotional icons. And then, but you can see at first we don't see the student's face, because they are just represented by stylized icons. Then I say, why not? Let's also get the real face of the students. There's some problems because if you, because the students and the teacher, they are geographically dispersed over the United States. And some of them may be staying at home and not in a broadband situation. They could be even using a slow-speed dial-up line. So the bandwidth is a concern. So if every image is, 20, 60,000 bytes, that's too much. So we have to have more reduced size of images, preferably just a few, preferably just one, and do image processing, image reduction, so that the the participant can communicate either using the emoticons, original emoticons, or they can replace it by their own face at their own discretion, because I don't want to impose this on anybody for privacy concerns. So if someone doesn't want to use or show his or her real face to people, it's his or her choice. But if they don't want to, in fact, they only need to submit one image to the system. A normal picture. And it's amazing that what the visual grammar can do. What we did is that, I should say, what my student did is really all his work. Jin Li, a very clever student. You know, as professors, we report on our students' achievements. So we did, not like Mark Twain, me and my tapeworm, no tapeworm, my students. What he did is that he used some visual grammar and replaced the eye and the mouth area. And of course, you have to do image smoothing and the like, so that image look natural. And in fact, he can, from a base image, generate the smiling, the sad, winking, and crying expressions. We did also limited test, asking the subject to identify the emotional state and compare with two images. And the results very good, up to, I forgot the percentage. It's over 90% of agreement. You know, even you see the real person's expression, sometimes we make mistakes, right? I never know whether my wife is angry or happy, you know. That's that kind of thing. So you never know. But okay, so in fact, this one get reported by the tech review recently. So now let me show you some demo. I hope it works. If it doesn't work, you must excuse me. Sunny, please tell me if I run out of time. Okay, I can stop anytime, you know, so it's not a problem. In fact, we have tools for student and tools for teacher, and they are different. Student has more limited capability. Teacher can control the access of the student and their privileges. For example, I cannot allow all the students to push their pages. That would be chaos. So I can give permission to select a student to push their pages. Likewise, I can limit the student's ability to upload or download the images. This is to prevent mischief. If the student, say, try to push porno, of course, we have to stop that. I'm just praying, hope that he's online. No name server found. He's not online. Well, now you have just to take my word for it. Later on, I try to see whether I can give you the demo. But basically, what I will show you is how this works. So I can, in fact, when the student left-click on an emoticon, it will be like that. First of all, it will blink, and it will be enlarged so that the teacher can notice that. And if we do the right-click, then the image will show. Can you recognize the picture? It's Hugh Hefner with, what's his name? Michael, what's his name? Huh? Mike Jackson, yes, that's right. Yeah. Yeah. Okay. Okay. So the student really like this kind of system where they have control. In fact, they can upload images, download images, and replace their emotional state images at will. Of course, like I said, subject to approval by the teacher. So they must use images that are reasonable. Okay, next thing I want to talk about is more a software engineering application. Okay, in software engineering these days, we are always concerned about rushing the software to the product. Previously, we talked about prototyping. These days, people are not happy with prototype. They want so-called agile programming very fast, and be able to get the product to them very quickly. So working with, because I'm at University of Pittsburgh, and we have very strong medical school, so many of our research in collaboration with the medical people. So we are always interested in rapid prototyping of time-critical applications. The picture should be recognizable. Oh, what are you doing? Okay, it goes away. That's a very successful example of rapid prototyping. You know, the Cinderella story, you know, when Cinderella wants to go to the ballroom, you know, I mean, she has no carriage, she has no servant, and she has no dress, in fact. And her godmother, who by the way, is a very good software engineer, she solved all the problems. So she converted the pumpkin into the carriage, the little mice become the horses, and so on. Okay. So I always use the example to tell my students what is a successful prototype. First of all, you must be able to adapt web services, components, and legacy software to design application. Use existing tools, existing components, just like the godmother used existing pumping. I'm sure the pumping exists to create a carriage. And second, it must be functional before the deadline and remain functional until expiration time. Finally, it must satisfy other user-specified time constraints. So that's our C pumpkin project. At first, I called Project Cinderella. Then I realized I really don't care about Cinderella. I care more about the pumpkin. Yeah. Okay. The part I'm going to talk about is just the first item, which is the IC card, because we use technologies such as IC cards for user-oriented scenario design. And this will create active index, which I skip, and using relational mining to find the appropriate pumpkins, namely components, to put together. And then there are mathematical analysis based on PictNet to do time analysis. I will only talk about the user part for specifying the first step, the scenario, the ICs. Those ICs, IC stands for the index cells. These represent active objects, and they can interact with other ICs. And the key point is that it may have different interaction patterns. For example, if you're dealing with in-house care, patient care, so the patient may have an emergency situation, namely his blood sugar level goes to 300, like I did one time. And then that information should be quickly sent through the computer network to the emergency management system, and the EMC should quickly dispatch a nurse or someone to visit the patient to solve the problem. So these are the interacting partners, or some would call them ICs, and I call them ICs. They interact. So for the prototyping, the user working together with the system designer will be asked to fill up IC card. Later, I'll show you our computer system that can do that again, if it works. Basically, you give the IC the name and the task to be done, the name of other ICs to communicate, what message you want to send to them. But most interestingly, you can see in the middle. Again, the color doesn't come out very well, but you can see that basically there are two human faces, one large and one small. And what are they? These are the complex icons, which consist of two icons that I use. Because if you look at the design of many systems, especially if the system is related to users, it's very important to know who has control, where to send the information, and timing. In fact, MIT used to have a journal, now of course it's no longer published, called Information and Control. These are two very important aspects in systems. Now, for several years I've been trying to work on the iconic language to capture this concept. Finally, I settled on a very simple icon. Now, you all know the smiley, smiling face. So this is kind of extend that concept. So basically, we only have a round face, the eye, and the mouth, just these three. The presence of the eyes indicate control. So, if I want to control something, I open my eyes, I see something. So if I close my eyes, obviously I don't want to control. So we always use the expression, I look the other way. This means you don't want to see, right? So if the eyes are present, means you have control. If it's not present, means you don't have a control. You are most likely a slave. A slave means that you receive orders from another one who dictate what you have to do. How about the mouse? Okay, if you have a smiling mouse, this means no work. Okay, everybody's smiling if you have no work. If you have a tight lip, this means you have to do work. Okay. So with eye, without eye, a smile or a tight lip, so this gives you 4 combinations. Okay, now I'm interested in dyadic communication. In other words, one agent talking to another. It's always the relationship between two. So 4 states and 2 agents, this 4 times 4, this gives you 16 different combinations. For example, the upper left one, both are blind, both are smiling. This is just a quiet state. Nobody's doing any work, nobody cares. Okay. And this is the typical situation where one person is in control. He's smiling because he's not doing any work. So he farm out. And the other guy is doing the work. He's the slave, blind, and he's tight-lipped because he has to do the work. Of course, in computer terms, this means that we have a control program and we have a number of subprograms. We just send messages to them. They do what it is supposed to do. And finally, you can see here, this is the most complex situation. Both are eye open, and both are tight-lipped because both are trying to be in control and both are also working. So you have very complex interaction. Complexity, I use a purple color. Purple, at least in the Chinese color scheme, symbolize complexity. And others as well. So in fact, after categorization, we find out there are basically 6 different patterns. And these are the 6 basic patterns from the most complex, the purple, to the quiet state. And the other colors indicate the various, for example, one person can be in control, give the work to the others, or both can be interacting, and so on and so forth. So when the person is doing the design, he is asked to choose a design pattern, one of the 6 patterns. In fact, this leads to different communication protocols between the 2 agents. If you're a computer scientist like I am, you know patterns become a big thing in software engineering. But everybody has a different view what patterns are. In my view, patterns means that you must have something visual people can see. And then that visual pattern gets transformed into some rules. So in our case, we have these 6 interaction patterns. So the designer can select one. This leads to different communication protocols. Now let me try to see whether I can run the system a little bit for you. It works, good. Okay, so this is the IC card management system. For example, I can edit an IC card in the database. These are the IC cards already in the system. You can see there's a card for the heart sensor, emergency management system, patient, and so on and so forth, because we are interested in medical applications. So let's look at the EMC. So you can see the IC card. And so the EMC, the interaction pattern is that work will be done by others with interaction. So the emergency management center is in control. It sends messages to others. So its task to dispatch nurse when necessary. And there is a time-critical condition saying that you have to respond in 15 minutes when a distress message is received. Of course, this is hypothetical. In real life, this could be shorter or longer. And it will interact with nurse and send message to visit a patient. And of course, there can be more than one card. The interesting thing is that for many simple applications, that's the only thing you need to do. You specify the cards, and I have the compiler to compile that into XML documents and translate that into index cells, and finally into JSP programs, and you have a working system. Of course, right now it's not yet rich enough because I have only 6 interaction patterns. And my interest at this point is to further elaborate these interaction patterns. Like I said, I believe all these patterns have a visual part and then have a part that's the rule. Okay, so at least this works. And of course, we can also add a new card to the database. And then you can choose, you can enter, it works, great. Your own names, choose a particular interaction pattern, and so on and so forth, and store that into my database. So my viewpoint is that when we do research in visual language, we not only need to look at the theory part, but we have to get our hands wet, look at application. From that, we can learn a lot. Because, like I said, all these icons, they don't work in abstract. They have to work in some concrete context, like this one. Okay. So I can show you, once we are done, we will translate that into XML documents. The user doesn't have to do anything. You can regard this as garbage if you like, but basically this is the output of the transformation, and this can be interpreted and executed. Okay, the last application I want to talk about is ambiguous icons. At first I said ambiguity is because you don't want to have icons with multiple meanings, right? However, this will also be helpful if, number one, you want to have a smaller icon set. Number two, you want to be able to express a very rich set of concepts. So if you have 1,000 concepts and you are allowed only to use 20 icons, what do you do? So, of course, you have to use not just single icons, maybe 2 icons, and even that may not be enough. Then you have to consider multiple meanings. That's, in fact, the situation that semantic compaction face. What this company does is they design little keyboards that pelagic patient can use. Typically, the person can use only one finger to touch the keyboard. With one finger, you don't want to enter a long, spell out a word. That will take too much time and effort. You want to get right to the concept. So the idea is to try to use icons, but in a minimal sense, so that you can express a rich set of ideas. I can give you one example just from semantic compaction. So they have on their keyboard, Apple. So Apple, and of course, then on the top they have noun key, verb key, adjective key, and so on. All right? So if you hit the Apple key and then hit the noun key, it means food. Because in this country, apple is regarded as a good example for food. If you hit apple and the verb key, it becomes eat. Okay. And so on. So you can actually also use a combination, iconic sentence. So they also have a icon with a sun. Either sunrise or sunset is sun. Okay. So if you hit the apple key and you hit the sun key, it means breakfast. See what I mean? But you see, here it comes to controversial. Why doesn't this represent dinner or lunch? Okay. Why breakfast? Yeah. So you can see there's always some arbitrariness, but language itself is always arbitrary. So what I'm trying to say is that ambiguity can be exploited in certain situations. And since we are interested in designing user interface, so I try to exploit this technique when we are developing the Chronobus system, which is a system for time knowledge management. Basically, this application generator. I'm running out of time, so I just show you some basic ideas and quit and answer questions. So like you can see down below, there are a limited number of icons, and the user can compose these icons into an iconic sentence using the horizontal operator which is colored blue, the vertical operator, which is colored yellow, or the overlay, which is colored red. So you can combine several icons and ask the system to interpret it for you. It not only interprets that, it actually creates the user interface as well as the API, application program interface, to the components so that you have a working system after you done that. Now, here's just an example. So there's the room icon, there's the list icon, and there's a hammer. Because in time management, in fact, in this case, it's a bidding system where you can place a bid saying that you need a babysitter from 2 p.m. to 5 p.m. And people interested in this job can then bid for that job. And of course, later have to pay back by returning the time you spent. Now, in the semantic table, you notice the hammer can signify both bid and place a bid, depending its spatial location in the iconic sentence. Because there's no reason to use two different icons. One icon in different places. In fact, people, they have better, it's easier for people to remember it that way. So by exploiting the ambiguity and judiciously defining the semantics, then we can effectively use just a few icons, in this case, to create user interface. You don't want to see this. This is the parse tree. And then we create the final iconic sentence and all that. OK, so in this application interface generator, the user actually has a way to exploit ambiguity. He can say the icon can have multiple meanings. And the system can help the user to make that work by specifying the semantic table. Is this good or bad? In fact, I still think this is controversial. On the one hand, it's good to give the user more control and let him be able to specify what icons have multiple meanings. But some would argue this will defeat the purpose of having standard icons, where the icons are non-ambiguous and always have fixed meanings. However, you always have to worry about you over-design the system, okay? You make it too strict, then very few people can use that. So this topic is really controversial. I don't mean I have the final answer, but we can go either way. Okay, I think I better conclude. Arnold Toynbee, in an article written in '71, he made the prediction that a language based upon visual symbols and icons will become an international standard of human-to-human communication. This is actually before the days of the Microsoft Windows. Well, actually before the days of Apple. In fact, Microsoft really stole all this concept from Apple. No, we don't want to go into that. Okay. So this is really a great insight, And if we think about what we are doing now, using our computers, using our mobile phones, we gradually that way. Okay. And the only thing I want to extend is that Toynbee was talking about human-to-human communication using a visual language. I think it's not just human-to-human communication. It's human-to-computer communication or human-to-machine communication as well. last but not least, there are many interesting research issues. Like I pointed out repeatedly, icon semantics, that's definitely an issue. I noticed some of the works to be reported in the conference. We'll dwell upon this. How to build visual language dictionary, what should be captured in the visual language dictionary. That's really interesting. Transcoding. What I mean is that if you have a visual language, can you translate that into speech? Translate that into another visual language, another transcoding. This will not only make your system more versatile, also save a lot of development cost. Not enough people are looking at those transcoding issues. Or let's say you have application, right now it's on desktop. Can you port it easily to the mobile phone? I very much believe in a few years that will be the only device we are going to use. Just like Star Trek, right? A communicator is everything. It may not have a desk beam, okay, or stun beam, but otherwise it will be very useful. Expert icons. Icons can be associated with rules, especially if you know the patterns. If you know the visual patterns, we know the protocols, then we can build in some expertise. I never believe the high-powered AI, but I believe low-powered AI will have a lot of use. In other words, the AI system need not be all powerful to generate a human being, but little AI everywhere can create wonders. Finally, visual reasoning, how to reason in space or in the visual world. Now, this domain, sad to say, now is dominated by people working on spatial information system, cartography, because they do have an interest in geographic information system and be reasoning in this Cartesian coordinate space. But I think this is really some area that can be exploited, especially if you talk about military applications. The last two, expert icons and visual reasoning, will have a lot of bearing. I'm sorry, but I started a little bit late, right? So I think I end up in time. So that's all. And the PowerPoint is with Sonny, and you are welcome to have a copy. Thank you. I'll be here all 2 days, but still, I would like to see whether there are any questions I can immediately respond to. Yes?
Chang, where would you say are the most central areas of research that are going on in this area in a general way in the community? We were trying to figure out where this area is growing. It seems to me there's a good deal of it going on in areas working with sign language, with international language. Is that where you see a lot of the attention coming from your work?
Like I prefaced at the very beginning, I'm a computer scientist, and in fact, most people working in visual language computing are computer scientists or computer science oriented. So we see the world differently as people more interested in human communication. So I cannot answer your question per se. So I try to paint a picture, a broad picture that we from the computer science side or the IT side, we are working on this kind of problem. And as you can see, many of these are centered around what we call HCC, which stands for human-centered computing.
Yeah, I saw the work that you were showing in terms of the language for computing itself. Is that a large and growing area?
The human-centered computing certainly is, yeah. Beware, the terminology change every year. We computer scientists, we like new dress, So now it's called ambient computing, okay. A few years ago, it's called ubiquitous computing. So the keyword change every day. It's when you're writing proposal, you have to be careful. Okay. Ambient computing means that you are in a room, so you are aware of the context, and so the term that used before that one time is context-aware computing, context awareness. I think those are too many, so now people call it ambient computing. Many of these are related to visual languages, human-centered computing, and the like.
Have you seen a lot of money? I mean, ambient computing is very popular with DARPA. I don't know enough of agencies, but these are DoD agencies that fund research. But DARPA was funding quite a bit of it in ambient computing about 5 years ago. And then it sort of disappeared in my screen. So I'm wondering if you see other sources with this funding.
DARPA is always looking at 20 years ahead, 30 years ahead. So they put seed money to motivate people to go in that direction. Once people go into that direction, they move on to other areas. That's what they typically do, yeah. So if DARPA moves on, chances are someone in the Navy, in the Army, other agencies will pick up, not the whole thing, because the other agency will be much more mission specific. So they will just go towards things that are most interest to the Navy or something like that. So you will not see the same scale of funding, but maybe more concrete that will lead to a concrete application. Yeah.
If there are no questions, thank you, Dr. Chang.
Okay.
I think we should probably take a 10-minute break and just kind of collect ourselves, and the bathrooms are just around the corner.
If you don't mind, I'm going to go ahead and get started so we can stay on schedule, and we'll just keep moving along. Oh, why it's there? Yeah. People have been asking me. This is a very unruly crowd. They just won't sit. Yeah, I was thinking, nah, I can go ahead.
So very quickly, before I introduce Dr. Duffy, I'd like to talk a little bit about this little one page. I printed this out last night. A man named George Sutton, who works with the glyphs and logs group, composed these as small little flashcards. And if you pull these out, and if you're familiar with glyphs and logs, I'll give a short kind of just rundown of what it is. Glyphs and logs are meant to be iconic, purely iconic language. The icons are composable, and they're sort of a replacement for language, but it's not a language that you can speak. And the icons are meant to be representational. So these flashcards are George Sutton's idea of how you might make these more intuitive to be able to understand and learn. Because in many respects, because the icon is very simple, and they end up being fairly arbitrary. And just understanding the icon from just the very black and white and very simplistic diagrams would be difficult. But with the picture in the background, it allows you to get a very intuitive grasp of maybe image is iconic, or how that symbol represents food or apple or bone or whatever it may be. And you can get these are open sourced, so using GNU free document license, and they're available on listsymbolics.us. So there's a little bit of information on the background for this. And without further ado, this is Dr. LorRaine Duffy, and she can introduce herself.
Thank you. Hi, my name is LorRaine Duffy. I work for Spayware Systems Center San Diego in San Diego, California. We're a command and control information laboratory. We've been there for about 60 years, and my area has really diverged several times in that area. So I'm going to give you a little description of the work and a little description of why we're here today and why you're here today to help us sort of grow a new area, we hope. So let me go back in a bit. First of all, I actually graduated from the University of New Mexico 3 decades ago. And I'm looking at that going, gee, you guys have gotten big in the last 30 years. Second of all, before I start the talk, this picture is important because it's going to give you some context for the kind of things I'm going to talk about. This is a MOP suit, an MOPP, or Mission-Oriented Protection Posture suit. If you'll notice, the most important part about this is, look where the gloves are in that picture. If you'll notice, the gentleman in the background has gloves, and the one in the foreground has one hand on his equipment. He has another hand down here. You notice he's not wearing his glove. His glove is attached to his suit because it's a chem bio suit. If he's dealing with a chemical attack or hazardous fire, everything is sewn together so none of the toxic elements get inside to his body. That's very important when we're going to talk about in terms of the area. So I want to give you a picture of what the world looks like for the folks that are working in the world that I represent, which is chem bio defense. and special operations, because those are the kinds of outfits that this is actually 2007 technology, but it represents a unique problem for people who are trying to communicate. And my background is actually in human collaboration and chat systems, and so I'm very interested in how they're exploited in this environment. You can imagine if they're going to chat with each other, that's going to be a very different prospect. So if you wouldn't mind escaping out of there and going into the briefing, which is the PowerPoint briefing. And then I'll get into the briefing itself. That's the Duffy one, right? And if you go into slideshow. Thanks. This is an area we call the future of tactical text chat. I'm going to give you a context, and actually, instead of going through the entire briefing, which could take a bit, I'm going to give you context and also requirements. So that'll give you a sense of how to center the conversations as the rest of the day goes, and give you a sense of why we think this is a very interesting and new topic area. So I'm going to do some caveats first. There's a large team that works with us in this area, and many of them are in the room. I'm going to introduce them later on. But the idea we came across was a problem set, and I'm going to start from where I started with the problem. That was in the movie Black Hawk Down. I don't know if you've ever seen that movie. It's a Marine Corps movie. It's basically a helicopter is downed in the center of a city. The team is actually dispersed, and they have to get back together for a reconnaissance point in order to get picked up and get saved. The locals are very angry and very hostile to the group of warfighters that are sitting there. The more interesting problem to me, and the one that I found fascinating when I saw the movie 5 years ago, one of the gentlemen actually had an explosion go in his ear, and he was deaf. And so he was deaf throughout the movie, and he had an extraordinary problem trying to connect with his cohorts. He couldn't understand them. They were speaking in English, of course, but he couldn't hear. And so everything moved to gestures to get him to get to the right point. They got separated in the process of trying to get to the reconnaissance point. And I started watching that process, and because my background is in collaboration and how people collaborate, especially in computer-mediated communication, it started making me think about gesturing as a method for information exchange. After that movie, I worked in a lot of areas. One of them was virtual environment building, and we built a number of virtual environments in the late 90s. And the problem was, how do you communicate to people the context they're in when you're not there to tell them about it? It's about symbologies and symbols and visual images, and we built an entire virtual environment that actually was a physical representation of a command center with desks and monitors and computers on tables, and avatars were 2D images of little stick figures walking around. Very rudimentary, and we thought, how much of that has to look real? So now speed forward 10 years. Now we're in the World of Warcraft, Ultima, and the number of games that are out there. And what we found in EverQuest, for example, is that the 3D environment has grown hugely. I mean, we were stuck in the world of VRML. VRML is a programming language that is rudimentary at best, but doesn't have the amount of money that normal gaming environments have, and so you don't see as much development in that area. Gaming areas use proprietary language, and if you've ever logged in, it's very realistic. And also disturbingly so if you've watched my son sort of blow up heads and the kind of visual images that have to do with bodily harm. It's astonishing to me how real it became, but it still belies the question we started with. How much does it have to look like real life for it to be communicative of information to you or to anyone? And that's still the whole area of symbology. So given those varied experiences, the question I started to ask in my work was, what happens if you have a team that doesn't have necessarily audio communications, doesn't necessarily have text chat communications? How do they communicate, and how do they get across what they're going to be doing in a rapidly evolving environment? So I want to give you these team definitions or environments to give you a sense of requirements for how this would work. You saw the ChemBio picture of a ChemBio officer. Today, when they want to text chat, which, by the way, I'm going to give you a description of how they text chat, they literally pull off their helmet, put a pencil in their teeth, and tap on a keyboard to get information to each other as best they can. If they're lucky enough, they're in a quiet environment, they can talk. They have unbelievably state-of-the-art audio headsets. And so I don't work in the world of audio headsets because there's plenty of commercial companies that work that world. Because also in ChemBio, when you're working a chemical fire, the roar of the fire is so huge and so loud, you simply can't hear anything. You can have the state-of-the-art you want in your headsets. It's not going to help. Secondly, think about a NASA space team. The next NASA space mission to the moon is going to be comprised of about 30 space astronauts. The problem we have is when the first group went up there was only 3, and they had really nice state-of-the-art audio headsets, and they talked to each other while they were on the moon. The next team had 30 people. You can't have 30 people talking to each other at the same time. How are they going to communicate what the current status is, if they're in danger, what the next part of the job is, and when do they all go back to the spaceship to have dinner? That becomes much more problematic in a large-scale team. Therefore, how do they communicate in language that makes sense? And that's where symbology and text chat became of interest. So those are problem sets that we care about. Third team is special forces, and you get these. My entire experience with these is always in the movies, so I want you to portray the movie version you have. Team out there in the dark, covertly trying to get to somewhere. They've got to communicate, but one, they can't talk because that will make them visible in terms of audio signals. They can text chat, but if they're in gear, it's going to be very difficult to pull out a keyboard and text chat to each other. So how do they communicate? And the issue of building a language that they could use very quickly to communicate their current situation became of interest. I hope you can see that across all these teams, they're different teams, but they all have the same common problem. They're just trying to communicate their current status, the next thing they're going to do, to watch out for while you're doing what you're doing. And how do you also historically keep that information so that if you have to go back and say, remember what I said 10 minutes ago, you have some way of scrolling back to it or getting back to that information. The archiving of text chat is of peculiar interest to us. The archiving of symbolic language is of peculiar interest to us. How do you go back and look at something and still gain the same context and information? All right, so given that as a background, that's the nature of this project. The other piece of information I'd like you to hold in the back of your mind as we talk, there's a new area of science called NBIC. It's nanotechnology, biotechnology, information technology, and cognitive sciences. It's relatively new. It came out of a number of reports commissioned from the White House as well as the National Science Foundation and a number of European science foundations. What they came to a conclusion in 2002 and 2003 is NBIC, which is NBIC, as I said, nanotechnology, biotechnology, information technology, and cognitive sciences. Those four are not four sciences, that's one science. And that is the nature of science for the next 15 to 25 years. You're going to see a melding or a molding of sciences together into one discipline. That is the peculiarity of the project that we're on. We're looking at a number of technologies with a number of different professionals and trying to mold them into something that makes sense from all those perspectives. So on the team that I work with on this particular project, we have psychologists, computational linguists, I have electrical engineers, mechanical engineers, computer engineers, software engineers, and an inorganic chemist. And in all of those, we have to define a language we can talk to each other about and a common interest in the area so we can grow it. It's really, really hard, so we're very rudimentary in this. And I'm addressing this to you because as you see science grow in the next 5 to 10 years, you're going to be talking to people in other specialties. We have the luxury of being very stovepiped in the academic areas that we're all very popular in, or at least have some expertise in and professionalism in. My problem would be that you're going to start talking to people who are outside your area of professionalism, and you have to be able to develop a language with those folks too. So we found it really fascinating that the people that answered our call for this conference when Sunny put it out was you're a very diverse community with really different backgrounds. And we're going to try to build this area into something that is a multidisciplinary area in the area of visual and iconic languages and see where it grows. It'll be exciting, it'll be extremely painful, and the only thing I know is that when you're trying really hard, you look the most inept. And so I want you to know that's my modus operandi. As I go through this, I'm going to ask for your indulgence here, but help me understand the area. And those are the kinds of questions I'll be asking you because I don't know your area, and I haven't had time to read in it. And as time goes by, I'll get smarter in it. But ultimately, I'm still trying to answer the question of when I have warfighters at risk, and as you know, I'm funded by the DoD, so I care about that problem. But I care about it at the point where firefighters today, when they're fighting a fire in any national forest, have far worse technology than the DoD does. They get what we cast off, essentially. So if we improve this environment, it improves the entire environment of emergency control and crisis response. I want to see that grow. So in fact, my background happens to be in humanitarian assistance. And that area in the military means that when you have a tsunami, when you have a Sri Lankan fire, you're sending military people to help out in those situations. So I wanted to give you a context for the military that isn't all about just fighting either. It's about the humanitarian assistance of it. It's about migrating these technologies beyond the DoD into the private sector and into the actual state and federal governments, state and local governments, because they get that. And so I encourage you to think about those applications because that's going to grow as we see more and more interest going into, for example, Homeland Security. You know, just being able to survive something like New Orleans again. We don't want to do it the same way twice. So, given that long introduction, I'm going to go to the next slide. This is the team that we've got. Many of them are in this room. As I said, very diverse professions, all trying to put together something that's going to be a relatively new technology area, which I'll describe in a second. We're funded from the Defense Threat Reduction Agency, which generally deals with chemical and biological, radiological, and nuclear defense. So if any of those activities happen anywhere, our job is to find technologies that improve our ability to respond to them or predict them. Next slide. I'm going to go now segue a bit to text chat. My other job is actually a Navy representative in the text chat collaboration area, so I have a background in the technologies in that area. What we found interesting, and I have a paper that described this, was I was working in virtual environments doing VRML kinds of development, looking at avatars and looking at really cool environments that would drive people to interact more consistently and more historically. What I found that when I wasn't paying attention was the Navy was driving itself to a text chat environment. They downloaded IRC off the internet and they simply built an environment that is incredibly productive, very prolific, and has tens of thousands of users. And so I'm going to give you a quick description of what that looks like. So text chat is what I'm talking about right now, simply texting your chat. It is not instant messaging, so be aware of that too. Instant messaging, I'm sure you're all familiar with because you do that on your phones. You do that just about everywhere. Instant messaging is a conversation usually point to point or point to a few people. You're having a conversation and when you turn it off, it goes away. That is not the environment I'm describing. I'm describing something that includes 500 to 800 chat rooms at any given time. It's a large community of people interacting. It's exactly what it sounds like, text chat. We're interested in it because we live in a world of intermittent connectivity. And so when our team works together, they work also with the conception that you're not going to have internet access for large parts of time. You're going to have it, it'll be discontinuous, it'll hook back up again. So the idea that it's very low bandwidth, we're talking about, very low as in 2.4 kilobits. We're not talking about T1 lines, we're not talking about what you get on cable. So given those, and if you've ever been to Farmington, New Mexico, you don't get cell coverage up there. So question was, well, at least most of the parts around it, right in the town it works. I'm fascinated by the fact that most of the research implies or assumes that you have large-scale, high-scale connectivity and you don't in arena. It's often discontinuous networks. So we call it intermittent comms. A strike group in the Navy is an aircraft carrier and 7 or 8 attendant ships. That's what we call strike groups. When I say CONOPS, what I mean is concept of operations. So it's how do they work on a day-to-day basis. In our world, they establish, a large number of hundreds of chat rooms. Every chat room has either anywhere from 2 people to 4,000 people interacting at any given time. And they go on in and out all the time. And they also do this for 18 months. So these chat rooms last from 18 months to 24 months in general. So these are things that last for a very long time. And they go on in time. What happens is they connect up with each other and give themselves information about the mission they're on, current area, baseball scores. They talk to each other about who they know. They're common when they're going on leave in a city like Hong Kong. All this information is basically interacted with in there. What's interesting about the Navy is that it works with something called the Joint Committee, which is actually, the Joint Community manages all the services together to have them aligned on a mission. So joint people watch over these service-specific people in these chat rooms. And they like it because in the olden days, they used to get together in briefings in the morning and in the afternoon, and they would inform each other what they were doing. That's how they coordinate. Now what happens is everybody lurks in each other's chat rooms to manage what they know. And by the time they get to a briefing, pretty much everybody knows what's going on. So it's an inherent but small risk that when you have services working together, the Navy doesn't necessarily get very tied closely with the Air Force. And it doesn't get tied closely with the Army. So how do you keep them aligned so they're going in the same direction? And this is part of the process they use. They text chat their directions, the way they go about doing their business. They do real-time targeting. They support edge users, people who can't get into the large-scale systems they have. They use it for immediate, what we call common operational picture updates. Common operational pictures, just like a radar scope. Whenever you go to an airport, they keep track of all the airplanes on the scope. We do that in any harbor for every ship around. We do that for airplanes around and for tanks. So if you're doing that and you're updating it on a constant basis, they use text chat to augment that by giving context. Because you can see an icon on a screen. That doesn't mean that you understand what the nature of that icon really means. You may know that it's from Bahrain, but you don't know what it is. It may be a fishing boat, maybe a family outing. All that information has to be gathered and put into that system by doing this contextual transfer of information. So they do general information updates. And we're seeing a lot more migration into the cross-domain. Cross-domain for us is cross-cultural. So we're working with many, many forces from many countries, and it's becoming increasingly evident that we're going to need better translation tools. And in fact, there's quite a number of text chat translation tools that are out there today in theater, where if I type in English, it automatically translates to 17 other languages, depending on who I'm working with. Very important. What's interesting is it's only text chat. It is not visual language. And as Dr. Chang was saying, there's a huge possibility of growing that visual language as a basic language all services can read and understand, so they don't have to go through a translation engine. So those are the areas that we look at. Next slide. Just to give you a sense, for those of you that are not familiar with text chat, I didn't want to assume as much. On the right, on your left, is what we call a defense message. What in the old days, as in up through the 1990s, messages were sent out all in caps in that particular message format. This is a very generic slide, but it shows you what it looks like. On the right is actually an internet relay chat between two folks on the internet. And what they have that we don't have in our current text chat is they have color coding. I mean, but it looks just as dense as that, and that's a conversation, and that's what it looks like today. So we're trying to understand how do you improve that so it becomes much more facile for numbers of people to read that text and understand what's going on. They're very good at it now. They develop personal ways of reading it so they understand who they're talking to. They understand who they're talking to in the way they use their speech patterns. It's interesting to us that there's an example of what we call a radio fist occurring. Radio fists, if you've ever read Malcolm Gladwell's book, Blink. They're the actual signature of the dots and dashes used in Morse code to identify a user. So we on the western side of the conflict during World War II could track where the German army was going based on where the Morse code, how the Morse code was being generated. The dots and dashes went in a certain pattern based on the speaker. And a fist is a way of it was a F-I-S-T, if you're not familiar with that. It's just a name for describing a user that you know specifically based on the cadence of their speech. Well, you're finding that happening on the internet all the time. There's a cadence of speech people use when they use text chat. And so we've not had a good science around identifying that and obviously exploiting it. Most interesting, I think, for most commercial vendors is trying to figure out if it's a woman or a man talking, because that becomes commercially or marketing relevant information to whoever's chatting. So that's an interesting area of research. There's not been a lot being done yet. We think there's a future. So this is chat for us. And in light of that, then what are the ways we can improve it? So the next slide, we'll talk about where we think we're going to go with this. So the objective here is to enable rapid situation assessment information. Situation assessment is exactly as it sounds. What's going on, what's about to happen. So how do you do that more quickly? And you notice that what I've shown you is a text chat capability. It's very time consuming. What's it going to look like in 10 years? And we decided, because this is a generated list from our team, it is not something that's universal yet. We'd like to find out how correct we are or not. You're going to help us define that, because we would like to see it, one, not be solely text driven. We think that would be very archaic. It's too slow, it's way too ambiguous, it's way too prone to mistakes. And we'd like to focus it on visual and iconic images integrated into the text, just as in instant messaging today when you use emoticons, just as in when you're gaming chat, when you're inside of World of Warcraft or Final Fantasy, you embed a lot of acronyms to mean things, you embed a lot of images that you can find that are easily built on the computer based on the keyboard you have. So how do you grow all that? We need to accommodate edge users, and I've given you examples of what edge users look like. They look like people that are come by officers, special operations, and edge users, people that are in minesweepers. Minesweepers, by the way, today don't get chat because they don't even have the connectivity for that. We're talking less than 2.4 kilobit connections. So how do you migrate a lot of information to very small symbols and send that along electronically? You have to integrate with we're very interested in the geographic land-based terrain issue. For those of you that have had any exposure to military, most of the images that you see are from 2525B, which is a military standard for images. There's like 5,600 images. Problem is it's basically terrain-based. You know, a tank goes on this particular piece of ground that looks hilly. It's very much about putting images on a map for location. But we're finding that there's a new area called computer-based terrain. So if you're looking at attacks on a computer and you've got a terrain map of your computer system, how do you describe that you have this attack going on? or that your systems are running healthy and everything's working fine, or that you have 3 clients down and 2 servers, but they're not connected to the same system. We don't have a language for that, and that very much speaks to what Dr. Chang was talking about, a growing language in computer engineering that describes the health and welfare of computer environments. But the language hasn't been consolidated nor solidified, and that's an area we're very interested in looking at, because in the coming environments that we see, unfortunately for warfare, it's not going to always be about people on the ground. It's also going to be about people that are housed in computer systems around the world. What happens if something goes wrong in a computer-based system in Sri Lanka that's monitoring an edge fire that's going there? We don't have any way of describing it except for the words I've used, and the concern we have is that as it becomes more complex and it becomes more rapid, how do you describe it to someone who also doesn't have a exposure to computer science? My concern is that many of the very high-ranking military people that are rising up are not computer engineers at all. You know, they come from a different area. How do you explain to a general who cares very much whether he has people live and die, that he also has to care about whether his computers live and die? It's an all-new world to us in that description, and I think you're going to see that through the banking industry as well. You see that the places we see that are in movies that talk about financial warfare. You'll see the big screens on the in any movie. It's my whole exposure to life is through movies. You'll see them doing these big situation assessment displays that show computer systems going down. They're big pipe diagrams. It's great if you're a computer engineer, but I don't get them. They look really fancy to me. But what does it mean when you have to explain it to someone who has to make a decision, that has to understand that problem as quickly as possible? You can't make them a computer engineer in the space of time that you have. So how do you grow that language? That's that bullet. And we believe it has to also incorporate object relationships and time. Right now we have objects on a display. For example, I mentioned earlier 2525B has things like tanks and ships that you put on a map. It doesn't tell you the relationships those objects have with each other. So how do you know they get along or they're tightly coupled? You don't have a language for that, iconically or in text. How do you tell that this is a progression of time in the last 5 minutes? They were friends 5 minutes ago, but now they're fighting. Well, they don't have a language for that, and we're interested in doing that visually. So how do you develop a visual and iconic language for that? So one of the issues for us is trying to find the discipline that we can go to for those kinds of object relationships we'd like to put into a description of the current problem. Next slide. All right, so these are the things that I've just said in terms of we would like to see it go to this, we would like it to see it go in this direction in 10 years. Here's where this is the description of what we think it will be in 10 years. It'll be augmented text. We don't think text will go away. I don't think you'll have a pure visual language in 10 years. You'll have a mix, just like you do today in emoticons and instant messaging. So what is the best mix for that? My concern is that I have, hundreds of thousands of kids that are sitting on Final Fantasy and EverQuest and World of Warcraft today talking like that, and they're going to enter the military in the next 10 years, little by little and then more rapidly. They're going to bring that language into the military, and the military really has to be prepared to deal with it so that it becomes sensible. I don't want somebody text messaging an emoticon of a happy face and a sarcastic tone, and the other guy on the other end doesn't know that, because there's no discipline, there's no library for it. So we should start looking at it so that it is appropriately interpreted by the folks that are embedded in the chat system. So we want to make, the rest of it is motherhood and apple pie, obviously. Easy to understand and visual. We want to make it, we call it I-18N because we're too lazy to say the word internationalizable. So that's just 18 letters between I and N in internationalization. Yeah. That's why they always say I-18N, because they're just lazy. But it amuses me.
For years I've been trying to sound it out and make it sound like internationalizable, and it never does.
Oh yeah, it's just the 18 letters in between. So security policy should be built into this environment, and it should be automated. You have to depict geographic, and as I described earlier, non-geographic or network-based battlefields, because we believe that will be the battlefield of the future. We have to be capable over very low bandwidth and intermittent connectivity. You can't assume everybody's connected all the time, no matter how much you think you could. Unless you're working for a bank, you're not particularly connected. Able to portray complex concepts more efficiently. Obviously, that's a given, and that's what really, I think many of you are familiar with that problem. These are, how do you take words that mean many different things and boil them down to what you need it to mean at that moment? Linguistically derived, we want to make sure we linguistically derived it. And what that is a very poor language for saying, we have 2 computational linguists in staff, that's Emily Medina and Aaron O'Connor. We decided rather than start from scratch, we'd look at what we had in the chat systems of today and see if we could figure out what it is they do today in the system and then what do we do with it next. So their job as computational linguists is to look at unstructured text. For us, it started with chat, but as you may be well aware, we have large-scale blogs going on in the military, and nobody's really analyzed them very closely. So we want to see if there's a growth area in that. We think that the tools for computational linguists are going to have to grow. I mean, they've started it's a relatively new field in that they've applied it to what's on the web. We'd like to see it become much more, I guess, able to handle the complexities of what happens in unstructured text. And the world of AI moved into formatted text. It's very easy to, if you have a formatted discussion, you can pull out the words you need and you go on with it, you can analyze it. But in unstructured text, you don't know what it means unless you know what the context means, and you can't do a numerical analysis of it. It's much more difficult. So that's one of the worlds that both Emily and Aaron are struggling with at this point. So we wanted to see that area grow. And the other area we decided was very important was we have to be keyboard independent. As I showed you in that first picture, you're wearing gloves in this world and you can't chat. It's very difficult to type. So what are keyboard independent inscription technologies? Inscription for us is just inscribing into the computer in some way, letters, images, whatever, to get it into the computer so other people can see it. So that's what we mean by keyboard independent. It's very much around the area of what we call wearable computing. So those of you that are familiar with any of Hiroshi Ishii's work at MIT, this is about being able to look in interfaces, immerse yourself in the systems, and have the capability of wearing electrodes anywhere and moving forward. The latest example we saw was Toshiba had an article in the paper about a electronified helmet in which if you think about certain concepts, they only light up certain areas of the brain, which then I don't know how to say this, it turns on a node in the helmet, and then you can turn on your remote. I don't know if you've seen that article in the paper. It's fascinating to me now that when you think something, you can actually turn on electronic equipment. The people that are investing in it very heavily is Toyota, because Toyota wants to be able to build a car that you can think your way through driving, rather than actually doing mechanical controls. That speaks back to the issue of the cognitive and biotechnology sciences I spoke to earlier. Think about what happens if you're trying to chat and you're actually trying to communicate something to someone else electronically and you don't want to type. That brings together several sciences, and I think that's the next generation of this science. So it's fascinating to me that the people that move this area generally are commercial entities like Toyota and Toshiba. Toshiba wants to build the man-controlled remote, as you might have guessed from that example I just gave you. So the guy doesn't even have to push his buttons. He just gets to think that he wants the next channel, and it goes to ESPN. Toyota cares about driving the next car, so you don't have to worry about turning on all the controls. You simply think them. So if you think about those perspectives, I mean, that's really where your visual and iconic language will end up. So think about that as you go through this process of listening to each other talk, because we think it's going to involve those sciences. Your work will impact someone somewhere, and it will be an electrical engineer, it'll be a mechanical engineer, it'll be a physicist, it'll be a nanotechnologist. And so how does that work? All right, so, and then we talked very much about, we wanted to consider an environment where, as I described the Black Hawk Down problem, it's a low probability of detection problem. We don't want people to be put at risk if they have to maintain covertness. It's not all that secret stuff. It's just about keeping people safe when they need to be safe. All right, so next slide. These are the three areas that we focused on as research. We have a linguistic research and analysis areas. I told you Aaron and Emily work in that area. And it's basically looking at current content of chat and trying to find out what it is they do in that area. We're working with Craig Martell back there in Naval Postgraduate School, trying to figure out what it is on the internet that's being used, how is chat being used on the internet, and what are the ways we can research it in a disciplined and mathematical manner. Visual and iconic language, Sunny Fugate is the lead of that, and that's the nature of this conference. We asked him to put together as many people from as diverse of areas as we could to bring them together on this problem set, because we think that there's a real growth area here, but we don't quite know who the community is. And so you're going to be interacting with people you've not seen before. This is our first interaction in this area, and I'm excited about the diversity here because I don't know where it's going to lead us. And tomorrow, part of that, and that's why there was such a heavy emphasis on discussion. We don't know where your science will take us, but we're hoping your science will help us coalesce, and that's what we'd like to see. So it's about building the iconic and visual languages. Sunny is a student here at the University of New Mexico, and we're hoping to have him grow that area as well here. And frankly, the first time I ever met him, we had a discussion about leet speak. He and Gary Rogers, our computer scientist, talked about how it was being used in gaming environments. And we said, well, if all the kids are out there talking in this leet speak is a mixture of icons, images, and letters off the keyboard to create a secret language, essentially. My son thinks, you know, that and it actually is very difficult to interpret. He uses it in his gaming environment. I can't figure it out. But it is about creating a cadre or a community among themselves. He uses it, by the way, my son uses it to maintain connectivity with his team. It means that non-team members are almost immediately identifiable because they don't know the ends, because it's all context-driven language. Well, it's about, the teaming arrangement is very unique, and I think it's very interesting for us. How do you use language and visual images to create a sense of teamness because you've had a shared context? All right, so that's what that area is. Technology of inscription, I'm going to give you a much more graphic description in just a second, but how do you build keyboard-independent systems? I have to tell you, when I first gave you the example of putting a pencil in their teeth and tapping it away, one of the interesting areas that came out of that discussion was we've built sensors for sensing anthrax in the air. The machines are actually the size of this table. It's huge. I don't know if you've read in the news about what happened with Chembio in Iraq, but we have Chembio machinery in the Humvees in Iraq. And they were all removed about 3 years ago because the Humvees had no armor protection. Remember when they brought them all back to armor them? Well, they got heavier. What happened was all the Chembio equipment was removed because it was so big and heavy. They're great big boxes. Well, now we're in this controversy about where we need, I mean, at some point, you do what's most important, and that was important. This is not a complaint. But there's been a migration of making sensors very, very small. And if you notice in every airport, the systems are getting much more innovative and complex. If you've ever been through that puff machine, you know, that sort of puffs you with air and basically analyzes if you've got any negative chemicals on you. That technology is growing. So the idea is that they've put it into a PDA size format. So it's a PDA size machine that you carry with you, and it can sense negative things in the air. And you just basically push buttons, and it tells people you're under stress or you're under attack. The problem is it's a BlackBerry keyboard. And if you remember what that glove looked like that you just saw earlier, it's really hard to type with a really big dish glove on a little tiny keyboard. So how do you change the inscription technologies is another area that is going to naturally be included in this area of research. All right, so next slide. I'm going to actually skip the details, thank you, of each area of research because I think you get the basis of it. So and they're in your books. I'll look them over a little bit more, but if you have more questions, Emily is working in linguistic analysis and using several techniques in computational linguistics to define what people are doing in chat today. Next slide. The visual and iconic language, you've heard Sunny talk, and he'll actually talk more in depth about his area of research, and so you're going to hear him talk about it, so I'm not going to belabor that. But the idea is to build a mixed media situation assessment language for us so that it would make sense for the use of this language to communicate rapid updates. Next slide. And this is a continuation of that information, and he was charged with putting together a conference, which he has done very nicely. Thank you. Next slide. This is an example of the kinds of languages he's come across in his research. And just for those of you that are not visual and iconic people in here, the idea that we started with sign language, and then we were looking at MIL Standard 2525B is up in the upper left. It gives you an example of the kind of visual images they use if you've not been exposed to them before. We all went to see Edward Tufte, and if you notice the middle layer in there, Edward Tufte talks about the visual communication of information and how you need to and also how you need to not make it extraneous, and also how not to use PowerPoint to communicate really, really important information. He does one of the most amazing workshops you'll ever be part of, so I encourage you to, if you ever have a chance, to see Edward Tufte's work. But the idea was that he boils down a great deal of information. So sparklines for us, what that should mean for you in this context is it takes a great deal of medically mathematical data and actually gives you a little graph that says, you know, if it spikes there, you could die. You know, that's what the whole point of information is. You're boiling down large data sets into visuals that will communicate the important information to you right away. And that's Edward Tufte's work, is how do you visually represent information. And then on the right is about net ops symbology. This is an area that Sunny has worked in quite prolifically. How do you explain that there's an attack on computers? And what is the mechanism for describing that? Very much a basic research area. And he's been looking more and more at bliss symbolics as a discipline in which to drive that ability to build iconic language. All right, next slide. The technology of inscription, I'm going to tell you really quick. It'll give you a sense of why mechanical and electrical engineers and physicists matter in this world. Most of you are based in the visual and iconic language field. But we have an agreement to make a wireless data glove in the first year. We're moving it into a gesture recognition glove. And we're eventually going to move away from a glove altogether and miniaturize it with nanotechnology and put it on your body. So you're not going to necessarily communicate with your hands anymore. You'll communicate with your feet and your shoulders and your face as you communicate information. But it's an interesting area for us because it drove us from this project. Go ahead and go to the next slide. This is actually a sign language glove. Two of my engineers on their own took a sign language class at our command. We have sign language interpreters. And they built this on their own just to see if they could do it. So Hua Fan and Nia Tran built a prototype just on their own time. This was not a military-induced exercise. They just want to see if they could do it. That's a sign language glove in which there's accelerometers on the points of the fingers. And what it does is it puts the letters on the LCD screen on the wrist, as you can see. Not sophisticated, but really innovative. And so if you do A, if you do B, you have to do this because C, D. I didn't want to do that with a real person in the room because I always do it badly, but it actually articulates that gesture and puts it on the screen. It was novel 3 years ago when they built that. So what's interesting to us was it's actually wired, and we said, all right, make it wireless. So the next screen will show you that we've got a wireless image. It's not in this view. But the wireless glove looks exactly like that one, but it communicates over 802.11b. And the idea is we started with sign language and realized sign language is relatively cumbersome if you're having to communicate to a wide group of people who don't have visual contact. You have to be able to see sign language. And so how do you interpret that into visual icons with gestures? And so, for example, when you do thumbs up, that's one image. You can turn into a static image that you can send very quickly over a network. How do you take complex images and complex words and turn them into an image you can send very quickly through a static gesture? So there's thumbs up, thumbs down, for example. But there's many, many examples of that. So how do you change that? And then how do you migrate it away from a glove into a wearable computing environment? And then finally, because I'm going to end here, the next area for us is how do you develop a large-scale ability to describe situation assessments? So this goes back to some research that started with us on something called Command Post for the Future. And in fact, that was the first time I ever came across Neil Cohen's work because the DARPA manager was interested in how do you just communicate large-scale situation assessment information in something more novel than PowerPoint. And he was looking at graphic novels and cartoons, and that's where Neil Cohen's work comes into play. And having spent the last 3 days chauffeuring my kids through Comic-Con, and having spent the last 5 years at Comic-Con, for those of you that don't know what that is, that's the comic convention. It's one of the largest conventions in the world, and it's all... It's number 3. Number 3? Oh, who are the other two then?
Angeloum in France, and there's one in Japan.
Oh, I believe it. Thank you. Well, I have to tell you that. All right, so my little side story, because I can always, this is what we do at Comic-Con. We all go watch movie stars. But my personal experience with this is I was talking on the phone with a gentleman named Ward Page, who ran the DARPA program about 7, 8 years ago. And in the discussion, he says, I'm going to hire Neil to do some work, just to look at this area. And we're very interested in his work. And I was on my way to the airport and turned on the radio, and he was being interviewed by NPR. And I'm going, oh, I know him. So it was really interesting. There was a little interview about you. And so it was about, God, it was, I don't know how many years ago. But, so I didn't know until then what it was about you. But trust me, it was exciting for me. The idea is that that area of research is just growing, and it's very, very new, and we just think that it's very much a start of a new area. And the reason I brought up Comic-Con is that for that much attention to be paid to graphic novels, it's important for us to pay attention to academically. There's huge ways of passing information on in a graphic and visual manner. Right now, the entertainment industry is driving all that. I would like to see us take that back a bit and see us do it in a more disciplined scientific manner, because then I think you can get real progress. I don't much care that the next Ghost Rider is going to be cool looking and has special effects. I care that the next technology is going to drive the way we move the area itself. So that was just a side image. If you go to the next slide. This is an example of, this is what we call a quad chart. This is how we have to work our world in the DoD. On the left is the objective at the top. The benefits are on the bottom. You'll see a graphic picture, and then you'll see sort of milestone things on. And that's a basic way we communicate iconically what our programs are like. The most interesting thing I think about this picture is, if you'll notice, there's a picture of Tom Cruise on there. And the reason there's a picture of Tom Cruise is that we went to go see a company called G-Speak. G-Speak actually invented the technology that Tom uses in Minority Report, for those of you who've seen it. Minority Report, there's a portion of the movie, Tom is my best friend, where Mr. Cruise is actually moving information, large data sets of information with his hands. It's very compelling as an exercise. Everybody remembers it, because there's white plexiglass boards, and he's clear plexiglass boards, and he's moving information with his hands just by moving it. Well, it looks like special effects. It's not. It's actually real technology built out of MIT. John Underkoffler was a student when the movie team came out to look at new technologies to portray in the movie. He spun off into his own company in Los Angeles called G-Speak, and they're building that for different venues, mostly for the entertainment industry. He's moved on to supporting the movie Eon Flux and a number of other movies like that. We asked him what that was, how that went about. What he built was optical bead gloves. And so they're very, very responsive time-wise. So as you gesture, it immediately controls what you see on screen. It's very compelling. What I liked was there's no training. You literally put the gloves on, as I did, and you look at something on screen and you pick it out. You can move it. You can scatter information. You can compile information using natural gestures. Well, if that's entertainment possible, then it's also, I think, day-to-day work possible. So we want to see that area as well. We want to see what is the technologies of immersion that take away the keyboard and embed us into computers so that it becomes more facile in terms of interacting. So that's where I'm going to end this brief, and then I'll just entertain questions. Yeah.
Hi, I'm Jack Ox. I'm coming from the art world and the music world, and I'm curious if you are aware of Stein, S-T-E-I-M in Amsterdam, which has been developing computer-assisted instruments for many, many years, and Michel Weisbich, who is the director, has a glove. And he's been using this for quite a few years to do his performances. And
For conducting?
No, it's actually, it's like it's computer, he has all these sounds that he's pre-recorded, and they are placed in space, like in a tree. And the glove, he accesses them, he's able to change octaves, information. And this has been going on for an awful long time, you know.
We're new to the area of art, and so you know I
But
don't
I mean,
know,
they
but
can
that would
actually
be,
inform you.
yeah, that's what I'm saying. That
This
would,
glove is real, and I'm not sure if it's wireless by now or not.
okay. But that's
I don't know how
irrelevant
they
to the
do
problem
that.
set. That's irrelevant to the problem set. The more important is that he's able to gesture and connect
You
with.
could find it online.
Okay.
Go to S-T-E-I-M.
All right, we will.
In Amsterdam, and
All right.
check out Michel Weisbich, W-A-I-S-C-I-B-C.
Okay, we'll find it. If it's Googleable, we'll find it. All right, thank you very much, because that's the kind of information we don't have access to given our backgrounds, and that's what we were hoping in terms of this community, that you'd all know different areas that have already migrated or moved beyond. Therefore, we don't start from the beginning, we start from the middle. That's exciting because they've already done a disciplining of their information, and so that's what I like about it. Thank you. I really appreciate that. So those are the kinds of things we'd like to see this conference generate. As you think of areas that you've read about or in your own disciplines, you may think that everybody else knows it in the room, they don't. So we're going to be taking numbers of, as I said, numbers of you in different disciplines and growing this. We'd like to see if we can actually grow this into something that also attracts funding to it. So, you know, what's the point of being in here unless you see, because those of you that are academic have to survive. Those of you that are in businesses have to see where the business direction should go. We want to provide that as a venue as well, because we think that's important to you and the health of this career area. So one of the areas we're looking at is supporting, in my world, chem biodefense as they move further into these new multidisciplinary research areas. So I'm busily getting very familiar with the folks that are interested in this area. As I said, chem biodefense is the first one that stood up and said, we're going to look at a revolutionary new science called NBIC. They're willing to look at multidisciplinary projects. That is the hallmark of the research itself. And they're very open to the ideas about what it would communicate, but they're very new to cognitive science and information technologies, and that's really where you all sit, as opposed to, I'm assuming, nanotechnology and biotechnology. But if you can also think back on your experiences about how animals communicate, we just had a discussion this morning, animals that communicate with you as they try to, and this was an article I read about in the paper today, in the article in the magazine. It was about persuasive techniques written by the editor of the Southwest Airlines magazine. He was trying to do a persuasionless day. He was not going to be persuaded by anybody or anything. So he gets up, and the first thing he has is his dog comes in and looks at him. In that common way dogs say, "I'm hungry." It's a gesture that dogs have, and he's communicated to his owner. So as you look at your research, I'd like you to think about the biology of the things that you look at, because I think that's also an untapped research area for visual and iconic language. How do animals manage to communicate that they want something? I know my dog kicks her food dish across the floor, and I know I got to feed her because she won't stop. It's simple, but it's also very effective. How do you take that and make it into a theoretical model and then move it forward? So would you please also think about those things that you've read about in the newspaper, that you've come across in your science lectures, that you think apply here, because I think there's a fundamental way of growing that. I'd like to use myself as a point of contact. Sonny will be the academic point of contact, and he can get a hold of me anytime, anyway, anywhere. You're certainly welcome to get a hold of me either through email or my phone number, which is my contact information. Let me know if you see a seed of an idea, and all I can do is address it honestly and see if there's some place we can figure out where it would go. There's this large-scale community out there. I'm interested in pushing DoD science and technology in novel directions, and that's my promise to you, is that at least I'll address the question seriously and see what I can figure out about it and help you. If I can't, then I'll let you know. But that would be my offer, and having you committed your time to this conference, we can only return the favor by trying to find serious venues of continuing research support and direction. I only have the DoD as a place where I can go. You all know your NSF foundations. You know of other venues. As you grow them, we'd like to communicate that across this community so that we can grow a community that can sustain itself. I'm going to stop here because 5 minutes ago was a long time ago. Thank you. I thank you for your time and attention, and I'll be in the back of the room if you have any more questions. All right, thank you.
Thank you, LorRaine. Our next talk will be given by Dr. Gina Thomas from the Air Force Research Laboratory. And we're going to get set up real quick.